Welcome to the UG students. Now we are going to that of the JAM question solution 2023. First question is that of the pinnacle rearrangement. In this pinnacle rearrangement, the cis diol undergoes rearrangement in presence of the H plus. The methyl group is always migrated to that of the hydroxyl group and it should be must be anti-position. Here the methyl group is migrated to that of the anti-position of the hydroxyl group and produces a carbocation which undergoes resonance to give the cyclohexanone derivatives. Here the trans diol, where the trans diol is present in the hydroxyl group diaxial position, under flipping it becomes to that of the equatorial position, and this equatorial hydroxyl group is anti to that of the alkyl group which undergoes migration and produces the cyclopentyl derivatives. In the given options, both Q and R gives positive filling test, means it should contain the CHO group, but in the given product does not contain the any CHO group, so the option A is wrong. In case of the Q gives positive iodoform test, but in the Q does not contain any ketomethyl group, so it does not give the positive iodoform test, so the B option is wrong. In case of the R gives positive iodoform test and its 1H spectrum shows singlet at 1.0 ppm and 2.2 ppm, means it contains the ketomethyl group, so it gives the positive iodoform test, and this methyl group is regenerated at 2.2 ppm value and this methyl group is regenerated at 1.0 ppm value, so the option C is correct. Again, the both compound contain the keto group, so it gives that of the Bredish reagent test, that is the 2,4-DNP gives the positive yellow precipitate, so the option D is correct. Next is the pK value of the cis cyclohexane 1,3 diol is always exist in the diaxial form, so due to that of the intramolecular hydrogen bonding, and after the deprotonation, first deprotonation, it produces the conjugate base which becomes very much stable and it has higher acidity. Higher acidity means it has lower pK value, but in the given problem sees that the pK1 of cis 1,3 diol is greater than that of the trans isomer. This is wrong. It should be lower. But in case of the trans cyclohexyl 4-tricyl-butyl cyclohexyl amines and the cis derivatives cyclohexyl amine, the conjugate acid become unstabilized by the 1,3 diaxial interaction, so it is lower basic, but here the 1,3 diaxial interaction is absent, so it becomes higher acidity, higher basic. In case of the 2,6 dihydroxybenzoic acid is more acidic than salicylic acid, this is option is also correct, where the 2 intramolecular hydrogen bonding is present in the conjugate base, but here only 1 intramolecular hydrogen bonding present. In case of the 2,4,6 dinitrophenol, the acidity is very greater due to the strong minus R effect of the NO2 group can stabilizes the conjugate base, but here only the minus I effect can stabilizes the conjugate base, so it becomes more acidic. This is the problem for the Favorsky rearrangement, where the benzyl cyanide bromide can react with that of the sodium cyanide to produces the benzyl cyanide, which undergoes hydrolysis followed by esterification, gives that of the methyl ester derivatives, which is not matched with that of the given product, so this option is wrong. Again, the chloro derivative of these ketone compounds undergoes Favorsky rearrangement to produces the cyclopropanone derivatives, which on cleavage to give that of the product which is similar to that of the same substrate of the C option. So the option B and C gives the same product, and the option D is also gives the same product via the Wolff rearrangement, where the ketene intermediate form which undergoes reaction with methanol to gives that of the desired product. Next is the alkyl addition to that of the unsaturated ketone. Alpha beta unsaturated ketone react with that of the trialkyl boron to gives that of the intermediate, where the boron contains the vacant orbital, and after the alkyl migration and the isomerization we get that of the 1,4 addition product. Similarly, the Gilman reagent always added to that of the 1,4 addition, and trimethyl chloride can quench in this enolate, and after hydrolysis, acidic hydrolysis gives the 1,4 addition product. But here the ethyl magnesium halide always gives that of the 1,4 and 1,2 addition product, and n-butyl lithium only gives that of the 1,2 addition product. So the option A and B correct. This has been taken from that of the Carothas group, where the trialkyl boron is always added to that of the 1,4 addition fashion and gives that of the 1,4 added product. The synthetic route of synthesis of 1-naphthol is that the first option is the preparation of the benzene from the 2-bromo-2-fluorobenzene derivatives, where the lithium can insert the fluoride derivative and leaving the bromide to form the benzene, and after Diels-Solder reaction followed by the cleavage to produces the 1-naphthol derivatives. And this the compound B of option B should produces only the naphthalene derivatives after the Clemmenson reduction followed by aromatization. But in case of the C, the intramolecular Fidelkopf acylation reaction followed by isomerization gives that of the 1-naphthol derivatives, and again the metachloroperbenzoic acid after Behr-Villiger oxidation followed by hydrolysis gives that of the 1-naphthol derivative. So the option A, C, D are correct. This is the problem where the electrophilic aromatic substitution will take place. In presence of bromine excess, the 2 and 6 position is more electron rich, so 2 and 6 position bromine is introduced, and after the reduction with that of the nitro group produces the amine, and the Sandmeyer reaction we get that of the tetrabromo derivatives, and these tetrabromo derivatives, the molecular formula of this tetrabromo derivative is 394. Here the molecular formula Br should be 4. So this becomes 394. Again, the isoelectric point of the glutamic acid is 3.22. In case of, this is the examples of the acidic amino acids. In case of the acidic amino acids, where we always consider the lower pK value, that is the lower pK value means 2.19 and 4.25, which under divided by 2 gives that of the 3.2. In case of the acidic amino acid, always the isoelectric point is more acidic, pH should be more acidic. In case of the basic amino acid, the isoelectric points always be basic type, means it always greater than 8. This is the some examples where the isoelectric points has been calculated. The sum of the total number of stereoisomers present in the following molecule. This is the 1,2-diol, butane 1,2-diol. It either OH group in the same side or in the opposite side. This is the erythroisomer and this is the thioisomer. Thioisomer is optically active and erythroisomer is optically inactive. Thioisomer optically active means 2 isomers, that is the DL pair. Similarly, the flipping is not possible in case of the transdecalene, but the amine substitution, amine must be in the above sides or in the below sides. It contains the 2 dual pair. It is also got dual pair, so total isomer becomes 7. The number of signal observed in the 1S spectrum is 3, where the methyl group is the A type, and this is the orthoproton of the methoxy group is 1 type, and this is the methoxy proton. So the option becomes 3. The amount of ethane produced in the following reaction is, it first converted to that of the mole, gram to kg to gram, then divided by the molecular rate converted to mole, and after the 90% conversion it becomes 64.27. When it multiply with the molecular rate of the ethane, we get that of the 1.92 kg. Thank you for the watching of this video.